Very happy morning to all. Am I audible? Yes. Very happy morning to all. Yeah, thank you, ma'am. A very happy morning to all the participants connected for today's FDP on machine learning and its real-time application. I'm Dr. T. Megla, coordinator for today's FTP. Let us start today's session with a quote on a Women's Day. A woman with a voice is by definition a strong woman. So I'm very happy to wish all the participants a happy Women's Day. And I'm very delightful to introduce a woman speaker on this Women's Day. With a very short introduction, Mrs. A. Ponmalar, Associate Professor, Department of Information Technology, Sri Sai Ram Institute of Technology, Chennai. Ma'am has pursued a BTech degree in Bharatidasan University, Tiruchi, and a MTech degree in Computer Science from Anna University, Chennai. She's having a 16 years of teaching experience and published more than 40 national and international journals. Her research interests include cloud computing, big data, machine learning, and information security. With this short introduction, I'll hand over the session to Mrs. A. Ponmalar.
Thank you, ma'am. Good morning, one and all present here. So I'm Ponmalar, Associate Professor in Sai Ram Institute of Technology. So I'm going to present the classification techniques in machine learning. Am I audible, ma'am?
Yes, ma'am. Yes, ma'am.
Okay, ma'am. So the title is Classification Techniques and Machine Learning. So machine learning means the human can learn all the information from the previous past experiences, but the machine, it doesn't have the experience. So it can learn that information from the data only. So we have to provide the data. Based on the data only, it will retrieve the information. So based on the knowledge, it will predict or classify the data. So here that is called as supervised learning. Supervised learning means we need to specify the label, that is the output value should be specified. In unsupervised learning means we won't specify the label value. So example of supervised learning is the classification. So classification means we have to classify the data as, for example, if it is an intrusion detection data, means it may be a intrusive data or not intrusive data. So true or false, or yes or no type answers. If it is a banking database, means the loan will be given or not given. This type of classification can be done with the help of machine learning techniques. So classification, that is a learning a discrete function is called as classification. Regression means we are going to learn the continuous function. So classification, so it's mainly several algorithms we are using nowadays. So traditional methods, SPM classification, decision tree. So there are many techniques we are following. Supervised learning, that is a type of machine learning technique. Here we need to predict the output value. It's based on the input value with a labeled exact correct output value. So here in training data set, we need to specify the sequence of set of parameters with output value also we need to specify. Based on the learning, it will find out the test data set. If you are giving the test data set, means it will correctly classify the data is it belongs to that particular data set or not. The algorithm is it's trained both the if you are giving the both the input as well as output we have to given. So the main goal of our classification technique is we need to find out the relationship between both the data sets, that is the input with the output data set. So this is the overall architecture of supervised machine learning technique. So first we need to specify the label data set. Label data means we need to specify the what is the output of that particular attribute. So then the machine will learn, first it will learn the training data set. So it will gain the knowledge. Based on the knowledge, it will predict when we are giving the test data set, it will predict that is based on the knowledge only, it will do the predictions. So there are classification. We can divide it into two. We can say it as a two-step process. That first we need to construct the model, then we need to use the model. Model construction means first we need to train the model with the help of training data set. Model usage means we have to give the test data set. So based on the training, it will give some predictions. This is the overall classification task. So training data set, here we have they have given 4 attributes, that is TID, attribute 1, attribute 2, attribute 3. So these are the input parameter, input data. So the first row, that is 1 yes, large 1 to 125K, these are the input data. So class means that is the output parameter, that is a label in supervised learning. So everybody knows that is a supervised learning means we need to specify the input data with the output label we need to specify. The here output label is no, yes or no answers will be given. So in training data set, we need to specify all the input data as well as label value. So after training, we need to specify the test data set. So here TID 11 to 15, these are the test comes under the test data set. So we won't specify that. We need to find out the class label, that is a label value. So based on the training, the model will predict the answer. It may be yes or no. The data and the goal. What is the main data? The set of data records or instances we are giving. So several attributes. We can give the several attributes. K different types of attributes will be given, starting from A1 to AK. So class means that is the output label. Each example is labeled with a predefined class. It may be a if it is a loan database means it will be approved or not. So yes means approved, no means not approved. What is the main goal of classification model is we need to predict the classes of when we are giving a new set of instances means that is a test data set. It should exactly predict the data will be that is approved data or not approved data. So if you are giving a new instances, it should correctly predict the output. So example data set, that is an example is loan application. Here different attributes we are using. So ID, age, and has job, own house, credit rating. So the output is that is a class label. It may be approved or not. Yes means approved, and no means not approved. So when we are when we are training the model, we need to specify all the input data with the label values. So this one is this data set is a testing data set. This is an instance of testing data set. So when we are giving age that is equal to young, has job equal to false, own house that is equal to false, credit rating that is equal to good means we can the load is approved or not. We need to find out with the help of training data set. So the model is first trained with the help of these data set, and the young has job false, so own house false, credit rating fair means the loan will not be approved. So sometimes it will be approved. Young age is young, they have a job and they have a own house, and the credit rating is good means the loan is approved. So the model is first trained with the help of these training data set. When we are giving, when we are asking the test data set, it will, based on that knowledge, it will predict it is approved or not. So the supervised versus unsupervised learning. Already I explained about supervised learning. We need to specify the label value. So unsupervised means class labels of the data are unknown. So here supervised learning, we need to specify every time when we are training the data set, we need to specify the input data set with the class label. Unsupervised learning means the example is clustering technique. So class labels of data are unknown. So learning and training data set and testing data set. By using the training data set, first the model will learn entire data set. Testing data set, so when we are giving the unseen or new data, it will predict if it is yes or no answers will be given. So accuracy means several evaluation measures can be used for classification algorithms. Accuracy means number of correct predictions divided by total number of test cases we are using. So training and testing. So overall diagram. First, in the learning, by using this learning algorithm, we can train the model. So when we are training the model, we need to specify the that is training data set with label values. First, in the model is trained based on that knowledge, it will predict when we are giving the new data set, that is a test data set, it will produce the result. It may then we can find out the evaluation accuracy or classification accuracy by using several parameters. One of the parameters accuracy. So data means that is the labeled instances, that is called as data. So that is a one single row, that is one record, that is called as data. So here xi comma yi value. Xi means that is a sequence of attributes that is called as xi. Yi is the class or label, we can say it is the output value that is called as y. It's we are using the parameter that is y. So in classification, in many cases we are using classification algorithm. So emails, it may be a spam or not spam. So by using a classification algorithm, we can find out this. First, we need to train the model with the help of several training data set. So based on this knowledge, when we are giving a new set of instances, it will predict if it is a spam mail or it's not spam mail. Features means that is attributes. So every time we need to several parameters. When we are using the machine learning algorithm, we need to specify several parameters. So in CNN algorithm, we need to use the hyperparameters. That is what is the kernel size, number of what is the dimensions we are using, what type of activation functions we are using. These are the experimental cycle. So every time we need to specify some of the parameters. So based on the parameters, we can implement that particular algorithm. So finally, we need to compute the accuracy or several evaluation parameters. We need to find out, we have to evaluate the entire result, that is a test data set. So it may be highly accurate result, means it's around 100% or 98%, 99%. So sometimes it will produce a low accuracy because of overfitting. Overfitting means so the testing and training. So when we are training the model, so we need to use several large volume of data. We need to train. So otherwise, it will produce some. When we are using only small amount of data for training the model, means it will. When we are training a small amount of data, small amount of instances, means after that, when we are giving a new data set, that is a test data set, means it will produce the wrong result. That is called we need to avoid the overfitting. So here example, data is loan application data. Task is we need to predict the loan should be approved or not. Performance measure, we need to use the accuracy. That is a major parameter used in the classification algorithm. So classify all the future applications. How many positive results we are getting? That is out of 15 rows, 9 rows label values are, that is class values or label values or yes. So 9 by 15, the accuracy is around 60%. So we need to train more number of records to achieve the high accuracy. It's a low accuracy only 60%. So several cases we are using classification algorithm, medical diagnosis, essay grader, fraud detection, customer service email routing, recommended articles in a newspaper. So several applications we are using the classification algorithm. So frequently used classification algorithms are decision tree-based methods, rule-based methods, naive bayes and Bayesian belief networks, neural networks, support vector machines, and many more algorithms are used nowadays. So fundamental assumptions of learning. So here the distribution of training examples is identical to the distribution of test examples. So in the test data set must be independent of training data set. If it is dependent means all it will produce a high accuracy, but when we are giving the new data set, it will produce the wrong result. So it will produce the low accurate results. So these two data sets are independent to each other. So it shouldn't dependent. As well as the training data set, when we are training the model, we need to train more number of data sets. So then it will produce a high accurate results. Decision tree. So here it's a very efficient algorithm that is a tree based structure. So we need to construct a decision tree. So based on the decision tree, we can classify, we can predict the test data set. So this is a loan data set. So already we discussed the same data set, that is a age, job, and a house, credit rating, if it is a loan is approved or not. That is a loan data set. So it's around 15 instances that they are given. So decision nodes and leaf nodes, when we are constructing the decision tree, so each attribute is represented in the nodes are used for representing the attributes. For example, in this here we are using around 5 attributes. So each attribute we can represent it in place of nodes. So each node is used for representing the attribute. So if it is a age is an attribute means there are 3 different outcomes it will come. Age, it may be young or middle age or old age. So the outcome of age attribute represented represented on the edges. So edges that is used for representing the outcome of attributes. Attributes are represented in each node that is used for representing the attribute. The each edge is used for representing the outcome of that particular attribute. If it is a age means there are 3 different age groups they are we can specify, that is a young age, middle age, or old age. So as well as a job means it may be yes or no, that is a true or false. Own house may or may not. So that is a true or false answers we can give. Credit rating, it will be good, fair, excellent. There are 3 different outcomes we can get it. So class means that is a final output of training data set, that is a label value, that it may be yes or no, that is approved or not. So age, there are 3 outcomes, that is a young, middle age, or old age. Then we need to check the next attribute. Attribute is that is the person has a job or not. If it is job, yes, true means the loan can be given. So we can give the loan. So true, that is the outcome label is that is yes. So job is no means that is false means they won't provide the loan. So no, the outcome class label is the leaf nodes, it will represent the class labels yes or no answers. So remaining nodes that is used for representing the attribute values, remaining edges that is used for representing the outcome of attributes. Leaf nodes are used for representing the class labels. So here age, there is young age, the person has job, yes means in this data set that is a young age group young. So they have a job, yes, true means they can get the loan. So yes answers in there are 5 rows representing young age group. So among 5 age group 2 members are getting the loan. So yes value that is 2, no value that is 3. So they are giving yes means 2 by 2 and no that is 3 by 3. Likewise we have to construct the tree. So each next attribute is they have a house or not. If it is they have a house means true means loan will be given, otherwise they won't provide the loan. So likewise credit rating, fair or good or excellent. So fair means they won't provide the that is they won't provide the loan. Good means they will provide. So among the training data set, among 5 instances, 2 instances that is representing yes label, remaining 2 instances that is used for representing so the loan is given, that is yes. No, only 1 record set. So among 5 record set, so credit rating fair means one record, that is they won't provide the loan. So here credit rating, so based on the credit rating, they have the young age group. So FAR means 1, 2. FAR credit rating is FAR means they will 2 records representing they won't provide the loans. Remaining in young age group, 3 records representing they won't provide the loan. 2 records that is used for representing they will provide the loan. So likewise we need to construct the entire decision tree. So based on the decision tree we have to find out the we can test the we can give the new data set and we can predict the value they won't provide the loan or not. This is the based on the training data set we have to construct the decision tree. So each node we need to specify the attribute, each edges that is used to represent the outcome of particular attribute. So this is a testing data set. Young age group has job false, own house that is false, credit rating that is good. They will get the loan or not, yes or no answer. So here in so based on the training data set already we constructed the decision tree. By using this decision tree we can predict this test data set will get the loan or not. Here age group is young, so here in this way we need to check young age group has job false, automatically they won't provide the loan, so the answer is no. Is the decision tree is unique or not? So everybody we can we have around 4 or 5 attributes, means different way we can construct the decision tree. So we won't that is not unique, so different way we can construct it with different answers we will get it. So to avoid this problem, so we need to select the which node should we select, which attribute we need to select first. In this example we selected the age is the first attribute we selected, that will be the root node. So it's based on the information gain value. So here they are using the entropy and the information gain. So entropy, by using this formula we can calculate the entropy value. So entropy value that is based on the positive samples and negative samples we can calculate the entropy value. So here gain, information gain. So by using this formula, gain of D comma AI, entropy of D minus entropy of AI. AI is a particular attribute. Entropy of D is the entire data set. So this is an example. Here in this example, first we need to select, we need to calculate the information gain by using that particular formula. So here first we need to calculate the entropy of D, that is 0.971. For each attribute we need to calculate the entropy values, the own house or age or some other attribute. So for each attribute we need to calculate the gain value, that is the information gain. So age information gain value is 0.083. Similarly, own house means 0.420, has job means 0.324, credit rating means that is a 0.363. So similarly, we have to calculate information gain for all the attributes. So then we need to find out which attribute is having the highest value. That is in this example, own house, that is a 0.420 is the maximum value. So the own house is the best choice for the root node. So similarly, so for we have a n number of attribute, means we need to calculate the information gain. Which attribute is having the highest value, we need to select that particular attribute as the root node. So if next attribute, next selected value will be the next highest value. Similarly, we need to construct the proper decision tree. So then it will provide the accurate result when we are giving the test data set. So evaluating the classification methods. So several parameters are used for calculating the classification algorithms or methods. So most frequently we are using the accuracy. Accuracy means the number of instances correctly classified, as well as total number of instances. For example, in our example 15 records we are using, in among 15 only 6 attributes, 6 instances are correctly classified, means correctly classified means the accuracy is 6 divided by 15. So the accuracy is around 60%. So similarly, every time we need to calculate the accuracy value for each algorithm. So efficiency means how many time required to construct the model, time to use the model. So sometimes it will produce the accurate results around 99.9%, but execution time is more than 1 hour, means that is not a best algorithm. So we need to provide the another parameter is efficiency. We need to provide the high accurate results with minimum time. Then robustness, we need to handle the noise and missing values. Several noisy data are included in the training data set. First, we need to perform the data pre-processing. After that, only we need to execute the algorithm. So every time we need to perform before execution, we need to perform the data pre-processing as well as data transformation. So then interpretability means that is understandable and the insight provided by the model, how much knowledge it will be provided. Then compactness of the model, that is what is the size of the tree, number of rules it will be provided. So based on the decision tree, we can construct the rules. So if you are constructing the very big tree, means then the rule is very big, number of rules will be increased. So holdout set. So holdout set is it's included training data set as well as testing data set. So training data set is used for learning the model, and testing data set is used for testing the model. So these comes under the holdout set. N-fold cross validation. So here the given data is divided into several n equal size disjoint subsets. Each subset is used as a test set. Remaining sets are used for training data set. So similarly, for example, we have partition into 10 partitions, means first partition is used for tested data set, means remaining 9 partitions are used for training data set. This method is called as n-fold cross-validation. This procedure is run n times, so it will provide n different accuracies it will be provided. So similarly, 10-fold or 5-fold cross-validations are commonly used. Leave one out cross validation means here only one part is used for testing data set. Remaining part, when we are giving a small data set, means we can divide only 5 portions, 5 partitions. Only one data set that is used for testing data set. Remaining data set that is used for the training the model. So validation set means there are available data. We have to divide it into training data set. Some data set that is used for validating the entire model. So some data, some portions that is used for tested data set. Most frequently 70:30. That is 70% of data that is used for training the model, and the remaining 30% that is used for the testing process. So accuracy is measured. Error means so accuracy error that is equal to 1 minus accuracy value. So already discussed about accuracy. Accuracy means number of instances correctly classified divided by total number of instances that is given. So precision and recall value. So here we need to, in every classification algorithm, we need to construct finally we need to construct the confusion matrix. Number of true positives, true negative, false positives, and false negative. True positive means number of instances correctly classified of the positive examples, that is called as true positive. Negative means false negative. F1 means false negative. The number of incorrect classifications of positive examples. So similarly, false positive means a number of incorrect classifications of negative examples. True negative means the number of correct classifications of negative examples. For example, if it is a cancer patient, means we are giving the data set, it will correctly predict cancer, means that is a true positive. So they are not having the cancer, means they will produce a there is no answer, means that is true negative. So likewise, when we are giving the data set, so after processing, it will, we have to find out the measure, we have to find out the, we have to construct the confusion matrix, that is true positive, true negative, false positive, and false negative. Based on this parameters only, we can find out the precision and recall measures. Precision means it's based on true positive divided by true positive plus false positive. Recall means true positive divided by true positive plus false negative. So an example of that is a true positive and true negative confusion matrix. So F1 score, that is another parameter that is used for evaluating the classification algorithms. So F1 equal to 2PR divided by P plus R. P is a precision, R is a recall. All these values, it's based on the true positive, true negative, false positive, and false negative values. ROC is another parameter that they are using. So that is also, it's based on the following four parameters: true positive, negative, and false positive, and false negative. Sensitivity and specificity. Sensitivity, it's same as true positive. Specificity, that is it's equal to true negative rate. So ROC curves, that is used for expressing the visual representation of true positive rate as well as true negative. Graphically, we can represent the true positive and true negative rate by using the ROC curves. So AUC is another parameter, they are evaluation parameter they are using. So evaluation metric they are using. So AUC is values that is equal to 1, means the classifier is very perfect. It's accurately classify the results. So AUC is 0.5, means some random guesses, 50% of possibility. So likewise, we can predict based on the AUC value. So an example for ROC curve. So some true positive values, negative, false positive. So based on the value, they have drawn the graph, that is ROC graph. So some other measures also they are using, that is scoring method and ranking method also they are using. So scoring is that is also related to the classification. So here some algorithms they are using scoring and ranking methods for prediction. So scoring or ranking is very high, means it's accurately predicted, otherwise it's not accurately predicted. So one more parameter they are using, that is lift analysis, that is also a parameter. So we here we need to divide the data into different bins, and they need to draw the curve. So how many positive samples we are in the bin, that is based on the value. They have to specify the result is accurate or not. So this is the example of lift analysis. So they have given 1000 test instances. Each bin they have a 210 actual positive instance. Likewise, they have given. Finally, they have to draw the lift curve. So what is the advantages of decision tree? It's very easy to construct. It's based on the information. Then we need to select the root node. So then remaining nodes there we can select it, and easily we can construct the model. So based on a model, when we are giving the new or unseen data, so easily it will be predicted by using the decision tree. It's very fast as well as, but it's very accuracy. Accuracy is also moderate accuracy will be produced. Disadvantages, so when we are training the model, it's very expensive. We need to spend more time. We need to resources are we require the more number of resources. So these are the disadvantages of decision tree algorithm. It can be complex compared with latest algorithms. So It's very difficult to learn. These are the disadvantages of decision tree. So then one more classifier is rule based. Already we discussed about decision tree. So just we need to construct a tree. Based on the tree, we need to find out the result. When we are giving the test data set, it will provide the, it will find out the output value. So the next method is rule-based classifier. Classify the records by using the collection of if-then rules. So condition-based, we need to write the rules. So based on the rules, we can predict the when we are giving the test data set, it will predict it will produce true or false answers. It will be produced. So condition, it may be a conjunction of several attributes. Y is the class label, that is the output of the input output value. The output value specified by using y label. So LHS we can LHS, that is equal arrow right, or HS. LHS, that is used for specifying the condition. RHS, right hand side, that is used for what is the output of that particular condition will be specified in the right hand side. So example of classification rules: blood type, that is equal to warm and operator. Lays eggs, that is equal to yes means. These are the condition. We can specify the condition by using the several operators and or not operators. So right hand side, that what is the output of this particular outcome? So it may be a birds, means the output is birds. Rule-based classifier, they have given a different data set: name, blood type, give birth, can fly, live in water, class, it may be a mammal or fishes, or any classes, different classes of output values they have given. These are it's around 20 instances they have given as the training data set. So based on the training data set, we need to write the rules. Different rules they have written. First rule is give birth, that is equal to no, and can fly, that is equal to yes, means the output is birds. So second rules they have, based on the training data set, we can define the different rules. Give birth, that is equal to no, and live in water, that is equal to yes, means the outcome is that is a fish. So likewise, we have to write the different rules. So based on the rules, when we are giving the giving the testing data set, it can easily predict. It may be a it can be a bird or a fish or mammals. So the rules are very easier to understand than the largest trees. Decision trees, decision tree, it's very easy to construct the easy to predict the outcome. So rules are very easier to understand than large trees. One rule is created for each path from the root to the leaf. So already we know. So from root node till leaf node, we have that is a path from root to leaf. We can write one rule. Likewise, if how many rules? It's based on the attributes, number of attributes. We can specify the several rules. So similar to the decision trees, they are using several evaluation parameters: accuracy, efficiency, and interpretability. So these are the several parameters, measures they are using for evaluating the classification algorithm. So next algorithm is naive Bayes classifier method. So naive Bayes algorithm is based on the Bayes theorem. So this is a formula: P of A bar B equal to P of B by A and P of A divided by P of B. So posterior probability, likelihood probability, prior probability, marginal probability. So based on the formula, so we have to find out the probability of for example, loan database. So loan will be given or not given. So we are given we can find out the probability value based by using this formula. For example, probability that is equal to 0.5 means 50% probability. So we can get 80%, 0.8, 0.8 means 80% of probability. Likewise, we can predict the output with the probability value. So they are giving some examples for neighbors example. So P of banana, the outcome, it may be a banana or orange or any other fruit. So 500 probability is 0.50, 0.30. So likewise, we can find out the probability value by using this formula. So one more example. So next, the question tested data set, if a fruit is long, sweet and yellow, what fruit is it? So by using the formula of that is base formula, that is a P of banana or long, comma, the condition is long, sweet and yellow means. So by applying this formula with probability value, we can get the value as 0.252. The outcome is point. So the answer is it may be banana, since it has the highest probability among all the three classes, 0.01. Orange, it may be orange means the probability is 0. So banana means probability is 0.252. Other fruit means 0.01. So among all three probabilities, highest probability is that is a banana. So the final answer will be banana. So next algorithm is SVM algorithm, support vector machine algorithm. It's mainly used for classification and regression. So here we need to, SVM is a support vector machine. So we need to draw the hyperplane. We need to segregate two classes. So for example, this is one example, squares and circle. There are two different data sets we are using. So we need to draw the hyperplane. It should correctly segregate two classes. That is a main aim of drawing the hyperplane. So in the hyperplane, we need to draw a different way we can draw it, but we have to find out the better way to segregate two classes. So margin means that is the distance from hyperplane to the minimum distance. That is for example, in this right side data set squares, we have squares. So in the distance between the from hyperplane to the nearest feature vector. Nearest feature vector, that distance is called as a margin. So when we are maximize the margin, we can get the accurate results. So when we are, sometimes we won't get the linear data, we won't get it at that time. We can get the non-linear data. So we have to convert the non-linear data into linear data by using kernel operations. So the kernel operation, by using kernel, several kernel functions they can use it. So by using any one kernel function, it will convert the non-linear data into linear format. So next one is K nearest neighbor problem. So this algorithm, it's mainly based on the nearest neighbors. It's based on the nearest neighbors. Majority of neighbors, they are having the particular group, means the test data set, it belongs to that particular group. That is the concept. So here in this example, for example, when we are the blue color, that is a blue mark, that is blue color square, it may be green group or red group or black group. So in this circle, a majority of feature vectors are green color. So this test data set, it may be maximum probability of it may be, that is a green color. So it's based on the nearest neighbors, we have to predict the data, the data label. So here minimum duration is it's more than enough for classifying the data by using KNN. So it doesn't produce an understandable model. So nowadays most frequently used SVM classification and CNN. So advanced methods nowadays we are using, traditional method is SVM. So nowadays also we are using SVM classification model, but CNN is For image classification means it's best way we can use the algorithm is CNN model, convolution neural network. So thank you. Is there any queries you can ask?
Participants, is there any queries? Ma'am, one question is there in the chat box. How to choose the optimal value of K in the KNN algorithm? Ma'am?
Yes.
How to choose the optimal value of K in the KNN algorithm? It's in the chat box, ma'am.
Yes, okay, ma'am. Based on the distance value. So we need to measure the distance from the test data with the remaining neighbor data sets. So minimum distance, that is a majority of labels, minimum distance, that is a based on the distance only, we can specify that particular data set, it belongs to the positive sites or negative sites.
Any other queries? Okay, it's time for vote of thanks. I'm Deepa, coordinator of this FDP. Good afternoon, everyone. I'm honored and lucky to have this opportunity to give a vote of thanks on this special day as it's Women's Day. Happy Women's Day to all the female faculties connected over here. On behalf of Sri Manakula Vinayakar Engineering College, I would like to thank our resource person, Mrs. A. Punmalar, Associate Professor, Department of Information and Technology, Sri Sairam Institute of Technology, for taking her precious time. We are really enlightened with your knowledge and presentation, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you.
And a special thanks to all the professors connected in this FDP. Thank you, professors. And I would like to thank our director cum principal, head of the department, and my colleagues for their enthusiastic support for organizing this FDP. Once again, thank you all. Thank you, ma'am.
Thank you, ma'am. Thank you so much for giving this opportunity. Thank you, ma'am. Thank you so much.
Punmalar, ma'am, thank you so much, ma'am.
Thank you, ma'am. Thank you.
And the participants are requested to fill the feedback form within 30 minutes of time.
Shall I leave, ma'am?
Thank you, ma'am.
Okay,
Participant will join us tomorrow at the same time. Feedback form has been posted in the chat box and it is also available in our YouTube channels. So please fill the feedback within 30 minutes of time. Thank you all. Thank you.
Ma'am, you can leave.
Okay.
போட்டுக்கு நல்லா சிரிக்க கூடாது லைட்டா